How do you do, ladies and gentlemen? I'm Julius Sumner Miller. Physics is my business, and we come again to some reflections on some of the great forces of nature. And we have again two of our young men, and I believe you have changed seats, Paul and Peter. That's a good exchange. Professor. I have referred to the various forces of nature, which leads me to suggest that all who hear me and all who see this program should secure at once a copy of On the Various Forces of Nature by Michael Faraday. Now, why do I speak of Michael Faraday, Paul? Let me tell you why. Because in the year 1736, he started in London the Christmas lectures for children at the Royal Institution. And there were hundreds like you who came and heard him and were inspired and stirred intellectually. And he was a great Scot who, correction, he was an Englishman. You see how I can make a mistake. But mistakes are made by human beings, right? Yes. Don't have to worry about making mistakes. See, some mistakes you can correct and others you cannot correct. This one I correct. So you should read On the Various Forces of Nature, because Michael Faraday here describes the very experiments we are doing. And if Michael Faraday could take time out of his busy life to explore these things, so should we. I have already said then that when the rubber rod is rubbed with fur, the rod, acquires by definition a negative charge. And we could also show, Paul, that the fur has acquired the opposite charge, or positive, which suggests what? That whenever one kind of charge appears, say the negative, the other kind must also appear somewhere in equal number, somewhere in the universe, okay? Yes. So, the rubber rod with fur, negative. Now supposing I take a glass rod and rub it with silk. We would then define the charge on the glass rod when rubbed with silk as positive. Now I must remind you that electrostatic phenomena are very, very tricky. Nature behaves in a very subtle way, and sometimes these charges do not arise in the manner I said, so you must be careful. But anyway, let's show another experiment. Here I have some nylon threads, and what have I done to them first? I have rubbed my hand over them to make them what? Electrostatically neutral. They have no charge. Now I'm going to rub the rubber rod with fur. Watch this. What am I doing? Work. And I am separating charges, positive and negative. Now I'm going to touch those strings. Watch it. I'm going to touch those strings. Well, let me do it here again. Oh, what do you see now? They're moving away from each other, and very forcefully. Notice how dramatic that effect is. Fantastic. Now, why are they doing what they are doing? They are not only fleeing from each other, but they are fleeing from the rod. Is it not clear that by making contact with the strings, I have rubbed off some of the negative charge that was on this rod, right, Paul?
Yes, Professor.
It now resides on the strings, and do not, like charges, push each other away. So look at that. Look at that. Isn't that fantastic? That is tremendous. That is fantastic. And do you see that it is at a distance that these forces exist? Look at that. I think that's wonderful. Indeed, when you read the writings of Michael Faraday, you will discover that in every fourth line he says, "Is not that wonderful to look at? Is not that marvelous to see?" So what I'm trying to do, Peter, is this. Have you stirred in the way Faraday was by these wonderful and dramatic things? You got it, Paul?
Yes, Professor.
Right, thank you very much. Now, let me bring up, since those are negatively charged, let me bring up this glass rod rubbed with silk. If now what I said in the beginning was true, or is true, should not those be attracted by this rod, right? Because they're negative and this is positive. Watch it now. Now, supposing they are not attracted, then somebody is going to say, what? The experiment failed. But I don't like that. Experiments never fail. Nature does exactly what nature must do. And if what happens is not what I predict, then have I not made a mistake somewhere. You follow me, Paul?
Yes,
See,
Professor.
nature doesn't make a mistake. Watch it now. We hope it attracts. Watch it. Oh, well, notice, there is a mixed reaction. There's, do you not see that there may be something wrong with my first announcements? Now, on a program of this sort, we cannot take time to go into all the intricacies of the matter. You understand that?
Professor?
But what I would hope is that you and your master, your science master, will do this, yeah? Let's go on and try something else. The glass rod rubbed with silk. Here are two little pith balls, that's the heart of a tree, hanging from silk fibers, from silkworm. Now, there's something for you to think about, young man. The mechanism and the behavior of a silkworm. See what I'm trying to do? Get you to think about everything, Paul. Get everything in nature. Watch. They are electrostatically neutral. I'm going to now bring this rod up. Touch them both. Do they not have the same charge as the rod? And are they not running away from each other and from the rod? Notice that. That is fantastic. Look at that. Look, look. They are fleeing as far as they can under the action of this force. So, some more experiments on electrostatics, again showing these remarkable forces of nature. And so, ladies and gentlemen, as is our practice, the two records, the Galileo and the Newton, to the school, and my book on milligrams to the men who have assisted me. And we shall have more of these things another time.